Axis for the torques, or is it?
Yeah, because you got
Okay.
left. You got rotate this way. What wants to rotate this way? I'm probably going to set this to be my radius of 0.
Really?
And the reason why is because it cancels out that force. Now, I could do it here if I want to do it here, but I really don't want it to rotate around this point. And whatever the mass is this, and this is this. It should be pretty easy to calculate this because they're going to be proportional to each other. I'll show you in a moment.
So
but this is the point at which I'm going to probably
19.6
rotate
the
around.
total, is that equal to 0.7 times 9.8 plus the unknown mass times 9.8?
Well, what about the ruler?
Plus the meter stick?
Plus the meter stick.
times
Yes.
9.8?
So let's do it. So first of all, the forces I would have, I've got a force this way, which is going to be 0.7 times 9.8. Agreed? I've got a force at this point, which is going to be 0.1 times 9.8.
Is that plus?
Yes. Well, it's going to be negative. I'm going to call downward forces negative for y.
So minus.
And then when I talk about torques, I'm going to do something different. I've got a force up in this direction, which is 19.6. Agreed?
Yeah.
And I've got a force over here, which is just mg. Right?
Okay.
Torques are good. So I'm going to go in the y direction. I have 0 because it's at equilibrium. I've got 19.6 minus 0.7 times 9.8 minus 0.1 times 9.8 minus m times 9.8.
And then solve for that.
And solve for m. I'm getting 1.2 kilograms. Is that okay?
That's what I got.
Why can't you do this without doing, like, why can't you do this torque first?
What are you going to get with your torque? You're not going to get the mass.
No, but you could do the mass basically sort of like this, but not exactly.
Well, the problem is you don't have mass or radius. You get two unknowns for the torque. Once I solve
Well,
the
no,
mass,
But what if you could figure out the mass as well by just dividing 19, what was it, 19.6?
well, that's why can you do that? Because you're summing up the y direction.
Yeah, but technically you don't have to do that.
That's what
Oh,
you're
that's
doing.
right.
You can say I'm not doing it because I did it in my head, but you're doing it. And when it gets ickier, it's better if we write it out formally. Ryan, be at the desk. Torque. Net. So I got no net torque. I'm going to pick this point here because it makes sense to me to pick this point here. Could I pick any point I want to? Yes.
Wait, why are you picking that like that?
Because it eliminates one of my forces, A, and B, it's really easy to tell you which one's pulling which way.
Okay, because you have
Sense?
forces on either side.
I force I'm gonna call this one positive because it's making it go counterclockwise.
Wait,
then
so
make
which
this
way
one
is
bigger.
it rotating? Is it rotating in like?
Hopefully it's
in and out of
rotating
the
in either
board?
direction.
I know, but which way are we?
I assume this, when I put masses on here, this is what it's likely to do. It's like the stick I have at the end here.
So it's rotating the y direction.
Yes. But the center of mass would not necessarily be moving. It might move, might not. I mean, theoretically, I could do it out of center of mass if you wanted to.
Well,
That might make more sense to you.
Yeah.
Doesn't bother me. I'm going to do that rope just because that one bothers me, and I know what to do.
You keep saying
Since we know where it's being balanced, can we say some of them are over total?
The problem, well, if you did it from this point, you could, because the problem is that this force is not a mass, right? So if we're trying to figure out what the net torque is, we're trying to figure out where I have to slide this so it doesn't, this is an outside force. Right. If you said, I want to make this the center of mass relative to this, then you could pull that off. Let's say it's 0. But if I've got two people pushing it, that would be a bad way to look at it, right? Because now we're not talking about a center of mass problem, we're talking about fat people pushing a stick around. Okay, so I canceled out this one. This one here is going to be 0.7 times 9.8 times 0.35, agreed? This one here, wait, because that's the distance between where the point I picked and where that mass is.
So now you're looking at the point where the mass attaches.
You can do it from the left. I said that. I'm going to do it from the middle because it makes more sense to me.
0.7
I'm less risk of doing something silly. What?
times 9.8 times 0.3.
Right, that's what I did.
Darn it.
Here, Doesn't matter in this case, turn out back torque, right? The only signs are going to be which way it turns it.
So you're doing it from where it's heading.
So since this is clockwise, I would call that counterclockwise. I'd call this one positive. Now I got the first force that you might forget is this one here, the center mass force, right? That's going to be negative. It's going to be 0.1. It is also 0.1 meters away, and that's 9.8. And then I've got minus, and I've got m, which we already solved for, 9.8 times the distance. What do you want to call it? X?
These are all
I'll call this
perpendicular.
X. They're all perpendicular, so I don't have to worry about it. Again, good question, because that's when you start putting a ladder on the side of the building or something not perpendicular. Then I just solve.
If you chose it from the left, would you have to make any positive or negative?
Yeah. The rope is pulling up.
Oh, right.
Everything else is pulling down. And you have a fourth force.
Right.
Don't drop your calculators. Mitchell!
Yes!
I fought the law and the law won.
Like last week.
How about 0.196?
Wait,
Is that what you guys got?
I'd like two more. Wait, is that not mine?
Sure. Want two more of those? 0.196? 0.196? So we would say 59.6 centimeters from the left-hand side, or something like that.
Wait, it said I was late on the 25th. Did we even have class on the 25th?
0.196.
Oh, yeah, I guess that's
So 25.
that was last Friday.
This is Friday. We had class of juniors did. So 0.196 from there. So you'd probably go back to the reference from the left-hand side
0.196 from the right.
to the right of where we tied it off. All right.
Wait, so what did you get?
See,
0.196?
it gives you the wrong side.
Why did you give the wrong sign?
Well, I guess if you're considering clockwise. Like it would give you negative 0.196, and then you have to say, oh, well,
Or even
because
the
this is why they-
Yeah.
it's
Yeah, it's possible. Although part of the reason why is because I put a minus sign here intentionally.
Yeah.
If I put a plus here, it would give me the correct side. It'd say to the right 0.196. So that's probably it's an artifact of the fact I made that a minus. I should have made it. I assumed it was to the right. I probably shouldn't have. I should have said plus and let it solve. And it would say, oh yeah, it's 0.196 to the right. So that's a me thing. Again, good physics would trump. I mean, there's no way it's not on the right-hand side, right? So, okay, try number two. Go ahead and start number two. Number two is going to make you cry because it's really, really hard. Except if you got it, in which case you're like, you won't panic and everything will go good.
But Mr. Esney, what if it's a helium balloon?
What's a helium balloon?
If the mass is a helium balloon, then I could go on the other side.
Yes, there'd be a forced buoyancy involved, which you guys don't even know how to calculate. No, that's part of the materials chapter, which I don't do anymore. I should probably, I'm going to do it not this year, but next year when I don't teach chemistry again.
Until you're going to teach chemistry, then you're going to teach.
It's like the most efficient, like lighter than air gas.
Like, what's the lightest?
Hydrogen.
What's the smallest thing you could have that would lift the person up? Like,
Hydrogen.
how big was
Well, its formula is real simple.